All right, I'm going to go kind of off notes for probably the rest of today and tomorrow. So you just got to kind of help me out here. I'll sound out the big words and spell them best I can. So what we were talking, so it's just kind of operation and things you need to know from here. So I don't know. We'll just use stars and circles and squares, numbers. So what I said just a little bit ago before we went on break, and I said, oh, I should really write this. So the position of the points opening, the position of the points opening is known as what? EGap, and that stands for efficiency gap. Efficiency gap. So one of the things that you have to do as a mechanic building these magnetos is you have to set that up. And you'll see how to do it. And you're going to put a little card here that has degrees on it. You're going to put a little pointer on top of the screw that goes to the cam screw right there. And as you rotate the magnet, that little pointer is going to go back and forth. So what you're going to do, and I love this magneto with nothing in it but the rotor, you can really feel that neutral position. Once you put the coil and everything else in there, you start to lose that feel. What's that about? So you put it in that neutral position. You know, this one's perfect. Bang, it just slams into neutral, which you should feel when you're setting up your end play. And then that is the 0 position angle, 0 degrees, I should say. And you'll attach a little finger to this, and then you'll move it 10 degrees. Would I turn it backwards or forward 10 degrees?
Forward.
Forward, because you're going to EGap, which is the number of degrees past neutral. So you'll go 10 degrees, and at that 10 degrees point, the breaker point should just start to open. Now, when I mean start to open, you look at it, you don't see anything. There's nothing to see. It electrically happens, and that's why you need that little buzz box, and we have a bunch of them, you didn't build one yet, that actually picks up the resistance change going through the coil, and it uses induction, vibrator and such, that it actually just senses the pressure being released, and it'll change the light. Boom, that's where it is. Okay, so you're going to set up that gap right there. Now you can go 10 plus or minus 4, but something you got to think about when you're doing this, there's the cam, there's the lobe. I tried to draw it kind of off sides. So on there's this little plastic thing, the cam follower. It's plastic, and we've got cam follower is going to attach here, and then there's a spring basically that comes this way, and that little spring is right here, and then I'll just draw them this way. Makes more sense that way. So you can see that it's going to, this right here is the spring, a little pivot point. And as it comes around on the high spot, we'll say that's the high spot of the cam, that's the high spot of the cam. It comes around to the high spot, or it's the ramp actually that's coming up on it. When it comes up the ramp, which is building up, and it starts to open them, that's where EGap is. Now, as I'm running this magneto over time, it is going to wear out this little plastic thing. This little cam follower is going to wear out. So as it wears out, what happens to the point opening? Does it start opening sooner and sooner, or later and later? Later and later, because it wears. So the cam has to travel a little bit further towards the highest spot before it's going to open. So they're going to open late and close early. Okay? So if I put this magneto, and by the way, so where the points start to open, EGap, but that's where it's going to fire when those start to open. So some of this you're going to have to write down because these aren't in my notes. I'm just thinking. So when the points open, what happens to the magneto? Say it loud. That's where it fires. The light changes on your little magneto box. Boom. That's EGap. The points start to open. It's also where the magneto fires, right? Because it opened up a little bit, collapsed the primary, induced a voltage in the secondary, voltage goes out, bam, we got spark, yes? Okay, So I'm going to take this, I'm going to put it in my airplane. I want it right at, say, 24 degrees. So I put it in, and it rotates in place so that I can fine tune it. So just by the way, the recipe for putting a magneto on is 4 steps. 1, put the engine where the number 1 cylinder is supposed to fire. Number 2, put the magneto where it's supposed to fire the number 1 cylinder. Number 3, put them together. Number 4, fine tune. You're done. I could add 5, screw it down properly. But it's so simple, is it not?
Once you understand it.
I don't have a problem with it.
Sometimes you gotta take it off and adjust and take it off.
Sometimes you gotta take it off 6 or 8 times.
Yeah.
Do it right. Okay. So I've got it in, and I've set it, and when I pull my propeller through, and I'm watching the little lights on my thing, go, wow, look at that! It's perfectly at 24 degrees. 24 degrees before top dead center on the right cylinder, and everything's perfect. And I go out and I run it for 100 hours, and I come back and check it. It didn't stay. How come it didn't stay? Now it's at a different one. Is it going to be later or earlier? Why is it going to be later? Because this little thing right there started to wear. So it starts to wear, so the rotating magnet had to turn just a little bit further, maybe 1 degree further, maybe 2 degrees further, to get the points to open, because you need to go closer to the higher spot of the cam. So it wears out. So now the magneto starts to fire later and later and later. That's why you check it every annual. That's why I check it every annual. So position points is known as EGap. EGap is the number EGap. EGap is, quote, the number of degrees past neutral at which the points open. At which the points open. EGap is a number set by the manufacturer, is a number set by the manufacturer and we just say 10 all the time because it's kind of the most common, but set by the manufacturer and adjusted internally by the mechanic. Now, in my little scenario where the magneto has wandered off and now it's getting later and later, so instead of being 24 degrees before top dead center, it's now 22 degrees before top dead center. That's later. The number gets smaller. I'm not going to go in and start changing the points. I'm just going to take the magneto off and tweak it a little bit. So just adjust it by 2. You can go in and start changing the points. It's a little more difficult, but you certainly can. But if you're going to do that, then I would actually want to take it out, set it on a bench, put the pointer back in neutral, make sure it's 10 degrees, and I would do the whole thing to make sure that it's actually where it's supposed to be, rather than to just get in there and just tweak them a little bit and go, good enough. I'd definitely do it. Let's see. Oh, I should write that thing that I wrote there. As the cam follower wears, the points open. Thank you. Points open later and close earlier or sooner. Not that the closing really has a big deal, but certainly the opening later has a big deal on it, and it changes the timing of when the magneto sparks to the engine. Happens slowly. So I guess then somebody could say, well, then if it's 10 plus or minus 4, we should definitely do it on the early side so it wears into the proper and then wears out to the... I guess if you want to think about it that way, you probably could. I don't. I'm just of the, if it's 10 plus or minus 4, then 10 is the number. I shared with you guys before that I'd read this somewhere and it really had this impact on me because it's always stuck with me. I don't know how true it is, but I believe it was true. That, and this is going way back, I think in the 70s, where Detroit, was the big automaker. And if you've ever had a 1970s anything, you know that it's a piece of crap. So they weren't built that great. And then Japan came along and started producing cheap cars that just kicked America's butt because they lasted and they worked. But anyway, the story I heard is that one of the big three or somebody, we'll just say General Motors, said, okay, they sent the blueprints for this transmission to somebody in Detroit and said, build the transmission. They sent the same blueprints over to Japan and said, build the transmission. Same pieces of paper. The one from Japan lasted significantly longer. And they noticed this, that they all lasted way longer than the American-made ones. What happened?
They're better at that.
Well, what they did is, and again, I don't have the source for this, so maybe it's completely false, but I don't think it is. So what they did, it was like that. So the Japanese would look at it and say, well, if it's 10 plus or minus 4, then the number to hit is 10. 10 is the acceptable. 11 is not, 9 is not. 10 is the acceptable. That's what you asked us. Anything other than that was a mistake and an error. As in Detroit, they're like, well, shoot, that's what? 6 to 14. 6 is just as good as 14. Now, what happens is when you're building something, you have to think about if you have a shaft, and that shaft is supposed to be 10 plus or minus 4, and then that shaft sits in a hole that is supposed to be 11 plus or minus something, right? You get the shaft well, that wouldn't work, but anyway, if you get the shaft all the way to the minimum and the hole all the way to the maximum, now you got all this slap going on in there, and it's like it's already wore out on day one. So anyway, when I built engines, I did it everything to the exact that I could. And sometimes it takes a long time to set something up exactly exact, but I just took the time and did it. Didn't bother me.
Getting paid for it.
Yeah, I could say I was getting paid for it, but there was a guy I worked with who was famous for saying this. Say it takes a whole lot of attaboys to make up for one aw shit. So, sometimes you may be getting the business from people for being just a little bit longer on that one step. But then if you did it really fast and it came back for warranty, they kind of forget how fast you did it the first time. So, and then if it doesn't come back for warranty and the customer's happy, they sort of forgot that it took you a lot longer. So, let's see, when breaker point, these are things I think we already have. When the breaker point's open, the primary coil was holding the original field in the coil core. Well, the magnetic resort, yeah, I don't want to write that. We talked about that. Secondary winding has 100 times the windings. The amount of secondary, the amount of voltage, the amount of voltage produced in the secondary is dependent on, what do I want to say, no. I want to say on the gap, the spark must jump. That's not what I wanted to say, but it's the same thing. The spark must jump. Not the, sorry to get all technical and whatnot on you right there.
You said the voltage was strong?
That's it. That's actually correct. It's dependent on the gap that the spark must jump. So as soon as the voltage, I can write as soon as the voltage is high enough to jump the gap, is high enough to jump the gap, well, it will. The voltage is the gap, comma, the voltage is dissipated to ground.
In other words, it jumps.
Exactly. In other words, snap, there it went. It completed the circuit. So even when I say it goes to ground, what is ground? Ground is just the opposite side of the circuit. It means it made its loop. Boom. Made a loop, and it doesn't have enough to keep doing the loop because you just, in other words, the primary was kind of the battery source, and you put it on and took it off real quick. So there you go. So the spark plug gap. The spark plug gap is about 0.018. Now wait a minute here. Spark plug gap is only 0.18
0.18 what?
inches. Look, my great granddaddy didn't fight World War II to be talking about millimeters, all right? Dang it. And there's just everything wrong with that statement. Because I don't think that's what World War II is about. And I don't think that. Anyway.
The metric system is common.
Yeah. Okay. So if the gap is only about 0.18, and I was just saying that the gap that you have to jump on the machine is, wish I could remember, it's about yay big. So that's, I want to say they give it in millimeters, which drives me nuts, but I can't think of what that was. So say it's half an inch. It's not, but let's just say.
13
It's
millimeters?
like 3/8.
Yeah, okay. So I think it's 5/8.
15?
It might be 5/8. So let's just say it's 5/8. That's a big difference, 5/8 to 0.018. So why am I testing it at this big old stinking gap?
To make sure it's not going to jump that far?
There's not as much air pressure.
Oh, don't ruin it for me. He's right. Okay, so that's 0.018, but that, if we think about and we compare it, on the machine, I'm jumping this, we'll say 5/8 inch gap. Why am I jumping that big gap? Because the spark plug, even though it's 0.018, air is an insulator. And when I shove it in a cylinder and I put all this air pressure in there, I am packing all kinds of air molecules around the spark plug, and the spark plug thinks it's this far apart. 5/8. Because there's so much air. So I put a bunch of insulator in there, and so electrically that gap is quite large. And that's why if you actually, and I could show you with the spark plug tester or machine, the way you test spark plugs is you put them in the machine, and you screw them in, you put the little lead in, and then you add air pressure to it, and you actually look in a mirror and look up at it, and turn on the air pressure, and it sparks, and it'll be blue. And then as you take the air pressure off, it just goes to kind of an orange, which indicates a very low voltage jump. So, did I have this on here somewhere? Let me see. I could write that. So here we go. Air is an insulator. So air is an insulator. Air is an insulator. The more molecules. In a gap. In a gap. The wider the gap is, electrically speaking. So while I'm on that subject, we got a problem. Not we, but don't freak out. So if air is an insulator, we'll look at our cap right here, and I've got my rotate my finger going around, and I want it to spark this particular tower right here for Miss Towers or that electrode. And I want this one, and I only want this one. If by chance I get it to accidentally flash over and spark one of the other two, then it's going to fire the wrong cylinder. And if it fires the wrong cylinder at the wrong time, I could end up with detonation, an engine that's not going to run, all kinds of problems. Certainly, best case scenario, it's going to run really rough and crappy, and that is going to make some poo come out and ruin your flight because you want the poo to come out. So it's important that when that finger is pointed to that one, it only goes to that one. So you can get a couple of problems in here. One is you can get something called carbon tracking, where it actually, and I did it in some of those examples where I just used a pencil because it's kind of carbon, and it will track over and fire the one next to it. So it misfires, fires the wrong one. That's really bad. And then you can get that from dirt, and once it starts arcing, it will create a carbon track and then make it worse. So once it's there, it starts getting really bad. So you don't want that. Second thing is, what keeps that finger is pointing at this one, but what really keeps it going to the one over here? And next to it.
Electricity? Movement?
Distance. It's quite a ways away. Well, it's quite a ways away, electrically speaking, because there's air in there. But what happens when I go up to high altitudes? I mean, really high altitudes. There's a lot less air. So there's a lot less air all over in the magneto. So there's less air in the coils, there's less air around the points, there's less air around this, less. You suppose this has a little bit of an effect on the magneto?
Just a bit.
A bit. So how am I going to solve that problem? How am I going to pressurize the magneto?
Put it on the case.
There's a little straw that comes out of the magneto. You can see them, and it goes in the cockpit. And the pilot, or you can get the co-pilot, they just... You got to do it like every 10 minutes, right? You run air pressure lines off the turbocharger, and you pressurize your magnetos. So pressurized magnetos is a thing. So it's not a big deal. What they do is they'll have a fitting that'll go into this side right here, and then rather than having vent plugs, they change the vent plugs. You want air to go through it. You don't want to just pressurize. So it's got a larger inlet, a smaller outlet, so you still have that flow through there. It's really hard on the magneto because you're taking and you're putting more stuff in it, air off a turbocharger, and so dirt and stuff gets in there. But yeah.
As the finger is moving, wouldn't it be causing more air also, since it's like a moving object producing air?
Well, but it doesn't pressurize. It's just like a fan. It doesn't pressurize. But so no. So we also have pressurized magnetos. So
Is this common? Pressurized mags?
absolutely, almost every time you have a turbocharger, expect to see it. Because a turbocharger means a high altitude aircraft. Certainly if it's a pressurized cabin, you're going to get pressurized magnetos. So in order to have a pressurized, all of that runs off the turbocharger. You just steal it from the turbo. So pressurized turbocharger with a pressurized cabin, almost guaranteed pressurized mags.
Does that take power away from the turbo, or?
It does, yeah. Yeah, you have, well,
Taking air away from it?
yeah, but that's a whole turbocharger thing.
Different thing.
Yeah, no, it is. It's a different class, but yeah, you're robbing air from it, so the turbocharger has to work a little bit harder, which means you have a little more back pressure of your exhaust. But
And hotter.
and the air's hotter and it runs hotter, and so. But yeah, but that's what they're there for. Okay, construction. I don't think we have to do construction. The case is designed to control magnetic forces, withstand heat with strength and durability, proper insulation to withstand electrical forces. Case is made of aluminum. What's the case made out of? The case.
Al Pacino. Oh wait.
The case.
Aluminum.
The case.
Aluminum.
Aluminum, with the exception of
Dual mags.
the old D2000. And what do you do with the D2000?
Throw it away.
Throw it away. So they're made out of aluminum. So cases are made out of aluminum. The rotor's made out of alnico. I have, or permalloy, whatever. Distributor is a dielectric material. Formica, bakelite. What's the other word? They're just a thermosetting plastics. So it's a plastic or bakelite or phenolic, you might call it. Depends on what they want to use.
How do you say the, was it Buna?
Buna? Buna N? That's a rubber. Buna's a rubber. All right. I think these are Q&A questions. Magneto. speeds. I don't know. This almost falls under one of those things. Is why would I have to know this? I can't answer that. All right. The number of cam lobes. The number of cam lobes. Where's cam?
On the rotor.
On top of the rotor. So, so what is the ratio of cam turns to rotor turns?
1 to 1.
Why would it be 1 to 1, Eric?
Because there's 2 lobes.
No?
1.5.
1.5. Come on, what do we got here? What is the ratio? The ratio of turns of the magneto rotor to the cam.
1 to 1.
Not the cam on the engine,
1 to 1.
the breaker cam.
1 to 1.
Why is it 1 to 1?
It's attached to
Because it's literally bolted to it. That's kind of my fault because you were thinking engine cam for a while there. Sorry about that. Does the camshaft drive the magneto?
No.
Not necessarily, right? It's directly related to that speed, but not necessarily. Because it's not directly related to crankshaft, because the crankshaft's idiot. It's the muscle. It's the idiot. The camshaft is the brains of the operation. Okay, it knows what's happening in the cylinder. So, all right. So, number of cam lobes.
Is this a whole new thing, or is this still part of the operation?
Magneto speeds. Right there. See, magneto speeds. The number of cam lobes of the breaker cam. So we're clear on that now. The breaker cam is equal to the number of poles. The number of poles on the rotor. So, if I had a 2-pole rotor, how many cam lobes would I have?
2.
Oh my gosh, 2. So the formula for that is if I have a 4-pole, because that's the next size, 4 poles, I have 4 lobes. Excuse me. I got the Rona. All right, I should stop saying that every time I sneeze. I'm gonna die. All right.
One of these times is going to actually mean something, and then
I know. I cried Rona too many times. Okay, so if I have a 2-lobe cam, I therefore must have 2 lobes. Well, if I follow that theory, I can't even see the rotor in there. No, I can. But I can't see how many poles are on it. But I can see the cam there, and the cam looks a bit like a square.
I got 4 poles.
So how many poles do I got on there? 4. All right. This is way easier than you thought it was going to be, huh? Okay. Also, while I'm thinking about it, a little bit off the subject, if this is a S6LN, S6LN, what does that mean?
6 cylinders.
6 cylinders,
Left-hand rotation.
left-hand rotation. By the way, if it's a -21, it means it has an impulse coupling. If it was a -20, it means it's non-impulsed.
What's dash 23?
Odd number, probably impulsed. I don't know what the significance is. Sometimes like a -23 means it has a taller breaker box. That's all it means. The case is just slightly different. Okay, so it's an S6LN. But being the super mechanic that you are, you decide that you want to make it go right-hand rotation. How do I do that? By the way, which direction is
Drive in.
drive end? Okay, but is this the drive end or is this drive end?
No, other side.
This side. Okay, so we'll all get on the same page. It's left when viewed from the.
Drive in.
Okay, fantastic. See that?
That was
Which way is the finger going?
Still going left.
Still going left.
Aren't they connected?
Oh.
Would it go opposite?
Yeah, but I turned it around.
Oh.
So right now, if this is going left, guess which way that distributor rotor's going?
Going right.
It's going to the right. But if I turn it around,
It's still going.
now it's going left
now.
again.
Oh,
So I remember that, right? Direction of rotation is when viewed from the drive end, but oh, guess what? That's going the same way. So it helps you. So if you say that's number one, the next one to fire is
One right.
going to the left.
Yep.
Going to the left, going to the left. That way. So it'll help you. Okay. Yeah.
On that dual magneto, you said that the cam it looks like a square, so you're saying that has 4 poles. I was wondering, does that mean each one's gonna have 2 poles on each magneto there, or is it gonna be 4 poles for each?
No, it's got one rotor, and so it looks like this.
Okay.
North, I think. South, north, south.
Okay, I get it. I thought you were talking about the poles.
No. And looking at the cam, it kind of looks a lot like that. So that's a lobe, that's a lobe, that's a lobe, that's a lobe.
Okay, I get it.
So 4 and 4. Okay, back to this. I want to make it be a S6RN. How do I do that? On the cam, if you look very carefully, there's a little arrow. So this is your secret, because when you build this up, it's going to be hilarious when when your magneto doesn't work. So here's your cam. There's a little tiny arrow that goes like that. And on the other side of the cam, there's a little tiny arrow that goes like that. So one side says that way, and the other side goes that way. So if I want to change the direction of rotation, take the cam off, turn it around, put it back on, and then adjust your brake, because now you're not at 10 degrees neutral, you're going to be the opposite. So, and then adjust your point. So when you put your magneto together, make sure that that arrow is facing the right way. If not, it's not a problem. You just start all over again. No big deal. Yeah.
You're saying that even though we flip it over, it's not from the drive end, it's still going to go left, but that's just for the distributor, right? Not for the cam load?
Well, everything else should be. Yeah, the distributor. I think you may have to be careful and change the tooth on there, because there's right and left, so make sure you have the right teeth.
Okay.
But I guess my big point was, it's the same distributor, it's the same part, everything's the same. The only thing you have to do is set the internal timing a little bit different, set your EGap different, and turn the cam upside down.
Because the engine will turn it the other direction.
The engine turns it the other direction. Yeah. It doesn't know. It's just going to go whichever way the engine does. Or I could have just said, hey, when you put it together, make sure you put the cam on the right way. What was I going to say here? The number of high voltage. The number of high voltage. I should just say, why would I want to just randomly change an S6LN to an S6RN?
Different engine?
Yeah, you wouldn't. That's illegal. If you're doing a home built and you went out to Kenny Faith, everybody know Kenny Faith? That's the aircraft salvage yard. And you just, hey, it's a home built, and you just grab one, and you're like, yeah, he's got a bunch of RNs, but I want to know when. I don't care. I can figure it out when I get home. You can. You don't have to worry about it. You just, if it's a home built, just re-stamp the R and the L, take it apart, put it back together, flip the cam over, and there you go. You don't need any different parts. So it works. The number, yeah, is your Sharpie or Vibrapine. Number of high voltage impulses. Yes.
Before we move on, I'm confused. So, okay, so the directional rotation is from drive ends, right?
Yes.
So the cam's on the other side. So if you flip it over and it's facing the right, going right,
Doesn't it still spin left?
doesn't it, yeah, would that,
Oh, let's take a look at
I
that.
kind of see what you mean.
original question.
So it goes to the left.
right?
See, that's actually going to your right here. Yes.
Right.
Okay, but I'm turning it to the left, and that cam has a little arrow on it. And the arrow just has to go the right way.
Okay.
So that hasn't changed.
Okay.
So, but but that cam gear, or the cam gear, the distributor gear, it is turning to your right. Yeah.
Yeah.
Turning to your right. Now it's turning to your left, and I haven't stopped changing. I haven't changed direction. It's because that way.
Gotcha.
And the cam lobe just has a little arrow on it. You just got to make sure the arrow goes the right way. Which, when you're looking at it this way, it's going to look like it's going to the right.
Okay. Yeah, we had like a 15-minute argument when we were putting our engine together about which direction it was gonna go.
Oh. Number of high voltage impulses. Boy, this one. Per full revolution. Per full revolution of the magnet. Of the magnet is equal to the number of poles. So a 2-pole magnet will produce how many sparks per one 360-degree revolution?
2.
Oh man, it's too easy. All right, so we're clear on that? Number of cam lobes is equal to the number of poles. The number of poles is how many sparks you have for a full revolution. So far, so good? Okay. The number of cylinders that fire per revolution, that fire per revolution of a crankshaft is 310, guys,
Half the number of cylinders.
is equal to equal to 1/2 the number of cylinders. In other words, we go back to that little animation I had. How many times did the crankshaft have to go around to fire that one cylinder? Twice. So if I had 2 cylinders, it would only, for 1 revolution, 1 would fire. Take 2 revolutions in them all. So in 2 revolutions, everything should fire. So that's often a question asked. So if I have a 1-cylinder engine, how many times does it have to go around to do all 4 events of that 1 cylinder? 2 times. How many times does it have to go around to do all 4 events in 2 cylinders? 2. How many times does it have to go around to fire to have all 4 strokes of a 4-cylinder engine? 2. How many times does it have to go around to fire all of the cylinders or all the events of a 1,000-cylinder engine? 2. Got it? Okay. But if it only went around 1 time, only half of them did it. The other half going to do it as soon as it comes around the other way. Got it? Okay. It was kind of a confusing sentence. I didn't like it so much, but just as long as you can get that. So I'll write that. All cylinders, all C-Y-L-I-N-D, all cylinders fire in 720 degrees. So that's two times. And really, I should be very careful about this. When I say fire, I'm really meaning, I should say how many revolutions for all 4 events. The intake, compression, power, exhaust to happen. It has to go up and down 4 times, which means the crankshaft has to go around 2 times. Where am I going with this? I don't even know. So if I put that all together, what ends up happening is the ratio, now you're like, oh, dang it, of the speed of the magneto to the crankshaft is the number of cylinders divided by twice the number of magnet poles. Divided by twice the number of poles. That's what I've written in my notes here. Or 1/2 cylinders, which makes more sense, divided by number of poles. So if I had, can I move over? Can't anyway. I'm out of room. I have to erase everything. This one right here is a 6-cylinder magneto, and it has 2 cam lobes. So what is my speed ratio here?
6 divided by 2.
So number of cylinders. How many cylinders do I have? 6. So we'll call it 3 divided by 2. 1.5 to 1. 1.5 to 1. So 2 goes into 3 1.5 times, so it's 1.5 to 1. What about this guy right here? How many cylinders?
4.
It's like 8.
2 for each thing?
No, 2, 4 for each.
Wait, go ahead.
No, yes, it's 2.
2 magnetos per engine.
2 magnetos per engine. So this
Each
is how many?
engine.
It's a 4-cylinder, and it has 4 lobes on the cam. Therefore,
2 divided by 4 is 1.5.
so it's 4 divided by 2 over number of poles 4. So it's 2 over 4. So it is
1.
1.
1/2.
1/2. 1/2 to 1.
1.5.
1 to 2. 2 to 1.
1 to 2.
2 to 1. All right.
I'm done. I'm done.
That's just kind of a weird thing to even have to deal with. All right. I don't want to spend a lot of time on that because you're not an engineer. You don't set it up. You put the right bag on the right engine with the right gears, and it kind of figures it out for itself. But just in case we need to know that, there we are. What do I have here? 4-cylinder, 2-pole magnet, 1 to 1. Oh, this would be a fun one, though. What if I have a 9-cylinder radial engine, which would be common. Radial engines have odd numbers of cylinders. I said a 9-cylinder radial engine with a 4-pole, which I don't think you would actually get, and I'll tell you, which I think would be impossible, but we'll go with it. Oh, no, it wouldn't. I'm sorry. It would, I would have to say, yeah, 4-pole. I'm sorry. It would have a 4-pole, 4 poles. I could never say it has 4 lobes on the cam. That would not be correct. I would say it has, and I'll tell you why in a minute. So radial engine, 4 poles. What is that? I did it the other way on my little thing. I said 9 divided by, it was twice the number of poles, 2 times 2, equals 9/8, which equals
1 1/4.
8 to 9.
Okay.
There you go. Or, what did you say?
1 1/4.
1.25 to 1. No. So the magneto speed, the mag speed to crank speed. All right, that's enough of that. We gotta clear it. Edit. Clear. All right. Super students. Talk to this side of the room. You guys remember the old compensated fuel pump? They're gonna be all twitchy and have nightmares.
Yeah.
Zach's going to come up here with my pen and tell you all about the compensated fuel pump.
There's the diagram.
It's like the hell I am. All right, well, there's something called a compensated cam. Compensated cam is a little difficult for me to explain to everybody at once, but let me see what I can do here. Just had a thought. Let me see. Where is that little thing? Oh man, I wanted that little animated engine. Because there are Q&As about, there we go. Stroke. Let me see. What? I don't have a radial?
Right there, right.
No.
That's a rotary.
Oh.
Animated radial engine.
They don't have it.
Google has it probably.
Wait, is the rotary the one where the cylinders spin around?
Yeah, the Wankel.
No, the gnome rotary.
Yeah, the cylinders.
That looks scary looking around.
Yeah, I've used this one before.
People with ADHD save 10 hours studying with this Chrome extension. But no, by all means, go.
Let's see what happens here. Just wanted a simple thing. So a radial engine is an engine that has its cylinders going around. So one is going up and over and over and down and around. You can have 3, 5, 7, 9 in one row, and then you start adding more. I don't think it gets more than 9 going around in the circle. But it's an odd number because the firing order, if you think, it goes every other one. So it goes 1, 3, 5, 7, 9, 2, 4, 6, 8, 1, 3, 7, 9, 2, 4, 6, 8. If you had an even number, it would go 1, 3, 5, and then blow up. 7, 9, then explode. So in a radial engine, you have what's called a master rod. You can see this is all one piece right here. It does not articulate. And these are called articulating rods. And they pin to here. And when the engine goes around and round, it really does not do it in a linear fashion is the word I wanted to use. But so when we have a horizontally opposed engine or a VA or any other kind of engine, right, a flat engine, V engine, you name it, inline engine, all the engines in the cars, the actual time, like if you timed it to the nanosecond, really, or between when this cylinder, am I out of time? Yes, I'm out of time. You guys are like all packing up and headed for the door, so I guess I can explain this tomorrow. I don't mind. Okay, 1 minute. So in all those other engines, every single cylinder hits at the exact same time right after the other. But in a radial engine, they don't, because it does this kind of weird thing, and it goes not in a perfect circle, but it goes in an ellipse. I'll get a better animation. I've got one. It goes in an ellipse. So there's actually a difference in time, physical time, between when this one fires and that one, between that one and that one. And so if you had the exact same camshaft on your magneto that was timed perfectly, it would misfire some of them. So a compensated cam, and I'll write notes tomorrow, compensated cam actually has the lobes in a different spot going around the cam on the magneto. And there's actually a little dot that you have to line up and say, this is the number 1, or the master rod.
Matched to the engine?
Uh-huh.
Because each one can be different.
Yeah. Yep. So there, we'll talk about that tomorrow.